Hello, brother. Now we will explain another or other file for our code. So the first thing is the simple file. We will explain the first one is the load data for 86 bus. So as you see here, this is the load for each passes from 1 to 86. So in each line, the first is the number of line, the second is the power, real power, and the third is reactive power. So for each pass, as you see here, maybe 40, the number of bus 40, the reactive power, the real power is 16, and the reactive is almost 8, and so on. And this is included in the load flow. And after that, also we define the voltage and power. The voltage of the normal load flow. This is after run the normal load flow, we get this result and put it here to simplify the code. You can run it separately, the normal, and get it the same result because the result is not changing from each one. So to simplify that, we printed or save it in this file, and also the power loss. This is the power loss in each passes. How many the power loss? This is the per unit power loss, and multiply with the piece MVA. This is also for simplify the code. And after that, the important code is the line configuration. This is the line configuration file function. So this is to the first thing to define which line is open it, and which is the configuration is applicable or not. This is the function of the line configuration. We have the output, 3 output, as you see here. The first thing is the line is closed, and exclude the open line, and the factor which is this configuration is applicable and contain the system is radial and all buses connected with supply. And the last thing is the L parameter. This is L is the which the line is opened. And after that, as you see here, we loaded the line data and define some parameters like F1, like FA, and N1. This is parameters. And after that, defined the number of line we can open it if you configuration the tile line 1. This is the tile line 1 configuration. So as you see here, this is the tile line 1. So, and this is all the line you can open it if you close the tile line 1. So this is the number of line you can open it if close the tile line 1. So the input is the index. As you see here, this is the index which line you should open it. So we were in our program, we optimize the index of the line that put it in this matrix or this row to indicate which the line is open it and applicable to open it with the tile line 1, and so on. This is the tile line 2, tile line 3, and until to tile line 5. As you see here, we can open it any of line from this. But if you make this assumption for that line to open it, why do you use the line configuration? Because we have two things, as you see, you said before, to contain the system is radial and contain the all passes is connected. But if you open it some another 2 tile line and open it maybe line here and line here, so maybe the configuration is will be some open the buses, and or in the combination between all the tie line, maybe the system will be not radial or will be not any some of buses connected to the supply. So this is coming important of this code. And after that, we put the line open it in the L matrix, and then we will start the line configuration to put it the line that not open it. As you see here, if the line is equal to the number of line here, this is the for loop for all the line available, and after that, if the line is equal the number of line in the for loop, so we will exclude it from the line and not saved in the line. This is the first code to put in the line variable all the line closed and excluded the line open. And after that, we check if the line is less than 86, so it's okay. This is also applicable, and you can enter this also while loop. In this while loop, you should to check what? Check if all buses connected with the supply or slack bus. And if not, we will, if the while loop continue and not reach that all the buses connected with the slack bus, so we put it the factor equal 1. So this is a solution not applicable. And also, after if the length of the line is less than 86, so also we put it the factor is as you see here is not applicable from here. And after that, we check all the buses is connected with the supply. The second thing from here to connect or to check all the buses is the radial. So as you see here, from 2 to 86, this is for check all the buses in the radial. So this is a function for check the network is our the reconfiguration is the radial network. Remain the network is radial, and this is for to check for all the buses that connected with the supply. And then we put it this factor is okay or not. And after that, as you see here, check also in this function, check also on this function the path, all the path in the network, as you see here from here. To check the path, in the all path, you should check all the buses included in the one path at least. So also to check the buses is included in the path, included in the line. That means the supply will be connected with each buses. And then if this not applicable or this some buses not included in the path, so we make the flag factor is 1. So and after that, this is the reconfiguration is not applicable if the factor is 1. This is the main object of the line configuration and how to select the number of lines. And after that, we apply on the load flow. After check the line configuration, this is configuration is applicable, is radial, is connected with the supply. So after that, we can apply the load flow on the reconfiguration. And the same thing, the load flow, we have some parameters we will explain in the next video.